We look out in the universe and 85% of all the gravity that's out there has some mysterious unknown source. We add up all the stars, the galaxies, the planets, the comets, the black holes, the dark clouds, everything out there that we can see, touch, smell, or taste. And it doesn't add up to give us the gravity that we see operating in this universe. So really we should be calling it the dark force, because we don't know if it's made of matter.
Have you ever wondered what lies beyond our current understanding of the universe? Some people speculate that it could be aliens, black holes, or even a multiverse. But the truth is, we don't know for sure. Considering the vastness of the universe, anything could be out there. Join us as we combine imagination with research and let our sense of wonder guide us into the possibilities of what could exist beyond our universe. Number 9. The existence of the multiverse.
Now, the multiverse is something that has come at astronomers and physicists from a number of different angles. It seems that there are a number of problems in physics and astronomy could be solved if there were not just this universe, but an infinite number of other universes.
The concept of a multiverse is fascinating since it provides an insight into worlds beyond our own. It suggests that there exist numerous worlds, each with distinct circumstances and physical laws, including our own. Although mostly theoretical, this concept is backed by mathematical models and discoveries in quantum physics and cosmology. It inspires curiosity about the boundless possibilities, parallel universes, and the essence of life itself.
There's no question the multiverse is having a kind of moment in popular culture. You know, Marvel movies have been leaning into it. Doctor Strange and the Multiverse of Madness, various Spider-Man movies, but also Rick and Morty and Everything Everywhere All at Once. You might think it's the fault of physics, because physicists have been talking about a multiverse for a few decades now, both in cosmology and in quantum mechanics. But in fact, as often happens in Hollywood and elsewhere,
at least one of them will be exactly like ours. We're trying to reach an identical universe.
Now science comes along, physics, my own field, and says, you know, it's possible there literally are other universes out there, places where things are different. But there's different ways in which science can lead us to the idea of a multiverse.
As we ponder the complexity of this idea, we can't help but wonder if there are other planets out there, each with a unique story to tell. Number 8. Infinite universe.
Do you believe that the universe is infinite, ongoing, or does it just simply stop at a certain point?
Well, William, yes, I do think the universe is infinite, but of course I can't prove it. So far, the universe has allowed us to see 13.7 billion light years in every direction. And we can only guess what's beyond that. So, on the other hand, it's a pretty good guess that we're not so special that we're at the center. So, if the universe is not infinite, it's extremely, extremely, extremely large. That's a pretty good guess.
The concept of an infinite universe poses a challenge to our comprehension of space and time, leading to debates in both philosophy and science. However, there is strong evidence supporting the theory of an infinite universe. The geometry of space, as observed by spacecraft such as the Planck Observatory, shows that the curvature of the cosmos is flat. This suggests that the universe extends limitlessly in all directions.
We have a stand at the Royal Society Summer Exhibition, which is all about the Planck satellite. This was launched in May 2009 and has spent all the time since then mapping out the entire sky to drill through all the different foreground emissions, remove those, and reveal the cosmic microwave background radiation.
Additionally, the hypothesis of cosmic inflation, which describes a period of rapid expansion in the early universe, lends support to the idea of an infinite universe. Although the question of the exact size of the cosmos remains a topic of interest among scientists and thinkers, these findings suggest that it is indeed infinite. Number 7. Higher dimension of space. String theory is a fascinating concept in theoretical physics, which suggests that there could be more dimensions to our universe than what we currently know.
Imagine I have a beautiful tree that's filled with oranges. And I ask myself, what is the orange made of? How do I answer that question? Well, I want to look deeply inside the orange, so I magnify it. And I magnify it again, and if I keep on doing it, deep inside, sooner or later, I begin to see molecules. But molecules are not the end of the story, because the molecules, I can enlarge them. And if I make them big enough deep inside, I begin to see atoms. Atoms are not the end of the story too, because we have electrons zooming around the nucleus. Deep inside, mostly empty space in the atom, but deep inside, we see the nucleus. So if I grab that and magnify it, I see that the nucleus is itself made of particles, neutrons and protons. And if I grab one of the neutrons and magnify it, I find yet further particles. Little tiny quarks inside. Now that is where the conventional ideas stop. String theory comes along and suggests that inside these particles there is something else. So if I take a little quark and I magnify it, conventional idea says there's nothing inside, but string theory says I'll find a little tiny filament, a little filament of energy, a little string-like filament. And just like the string on a violin, I pluck it and it vibrates, creates a little musical note that I can hear. The little strings in string theory, when they vibrate, they don't produce musical notes, they produce the particles themselves. So if I take all of this back together, I have my ordinary orange, and if these ideas are right, they are speculative, but if they are right, deep inside the orange or any other piece of matter is nothing but a dancing, vibrating cosmic symphony of strings. That's the basic idea of string theory.
According to this theory, the universe is made up of tiny, vibrating strings instead of particles. To make the mathematical principles of string theory work, scientists propose the existence of extra dimensions linked to time, in addition to the three commonly known spatial dimensions of length, width, and height. These additional dimensions, often depicted as compact and curled up at the subatomic level, could help explain some events that current theories cannot. Even though it is not feasible to directly observe these dimensions, their existence could provide a framework for integrating the fundamental forces of nature and bring us closer to understanding the mysteries of the universe. Number 6. Black hole universes.
What is inside a black hole? Inevitable crushing doom? Gateways to other universes? Weird multidimensional libraries? If you've ever wanted to know, then you might be in luck. Some physicists have argued that you are inside a black hole right now. Einstein's ridiculously successful general theory of relativity has never failed. But we know it must fail at the centers of black holes and at the Big Bang. Both of these involve matter being packed to infinite densities. They are singularities where the mathematics of GR breaks down. Well, it turns out that black holes and the Big Bang have more in common than vexing Einstein. They have mathematical similarities to each other that have led some physicists to believe that the Big Bang is in fact the singularity of an absurdly gigantic black hole.
The concept of a black hole universe captures our imagination since it brings to mind images of a universe dominated by black holes. Although this idea is hypothetical, theoretical physics provides intriguing insights into its possibilities. One theoretical argument proposes that the universe is closed, meaning that the gravitational pull of matter is strong enough to cause the cosmos to constrict instead of expanding. According to this scenario, as the universe collapses due to its own gravity, massive black holes may form and eventually merge, absorbing all matter and energy. The cosmic microwave background radiation, which is the remains of the early cosmos, offers additional information. Variations in this radiation suggest that the universe might indeed be closed, which would result in black holes dominating the universe. Even though actual proof for the universe with black holes is still unclear, these abstract ideas encourage us to contemplate the ultimate fate of the universe and the fascinating role that black holes may play in determining it. Number 5. Nothing.
But the amazing thing is, once you apply, in fact, quantum mechanics to gravity, as you were beginning to allude again in the last segment, then it's possible, in fact, it's implied, that space itself can be created where there was nothing before, that literally whole universes can pop out of nothing by the laws of quantum mechanics. And in fact, the question, why is there something rather than nothing, then becomes sort of trite, because nothing is unstable. It will always produce something. The more interesting or surprising question might be, why is there nothing? But of course, if we ask that question, well, we wouldn't be here.
The concept of there being nothing beyond the universe is a difficult one to grasp, yet it raises some intriguing questions about existence itself. Contemplating this notion compels us to confront the vastness of the unknown and the limits of human understanding. From a philosophical standpoint, the term nothing signifies the absence of matter, energy, space, and time in any form. It represents a void devoid of observable properties or features. However, the very idea of absolute emptiness brings up some pertinent questions. Is it plausible for such a state to exist? Or does nothing have its own existence by the hypothetical process? The question of what exists beyond the universe continues to be a topic of debate within the scientific community. While theories suggest the presence of other worlds beyond our own, such as the multiverse or higher dimensional realms, these concepts are not necessarily synonymous with nothingness in the traditional sense. Ultimately, the concept of nothingness beyond the universe stimulates scientific research and philosophical contemplation by compelling us to inquire about the limitations of human comprehension. Number 4. Evidence of previous universes. The idea of past universes is fascinating because it holds the key to unlocking the secrets of cosmic history. Although clear proof of previous universes is still not available, scientists continue to search for evidence in many places. The study of cosmic microwave background radiation, the hazy remnants of the Big Bang, offers one interesting opportunity for investigation. Changes in the CMB could offer clues about what happened before the Big Bang or suggest that the universe was born and died again in a cycle. Furthermore, theories such as cyclic cosmology and perpetual inflation suggest that there are multiple parallel or successive worlds, with our own universe being one of them. Although these hypotheses are still theoretical, they present opportunities to understand the circumstances of our existence. Even if direct observation may not provide evidence of past universes, scientific research is advanced by the need to comprehend our cosmic origins, and it is a call to explore the depths of space and time to find answers to life's most important questions. Number 3. A base reality outside our hypothetical simulation.
Ever since ancient times, people have asked the question, is the world a dream? Is everything around us an illusion created by some god to test us? Well, the modern version of that is the universe a computer game? Are we just dancing puppets, obeying the laws of some computer out there in the universe? Is everything basically a fake? Well, that theory got a tremendous boost with the Matrix series. Because in the Matrix, what we thought was real was actually a computer simulation put into our brain by aliens. And so reality as we knew it was all wrong. Is that possible? Well, the answer is probably no. Life is quantum mechanical. Life is not based on zeros and ones, zeros and ones. Photosynthesis, for example, is a quantum mechanical process. It is the basis of all life on the earth. And we still don't know quite how it works. a flower can do calculations that our most advanced quantum computer cannot. Amazing, truly amazing. So Mother Nature is still smarter than us when it comes to the quantum theory.
The idea that our reality might be a simulation run by advanced entities or technologies has greatly enhanced philosophical and scientific discussion. While this is still purely theoretical, some arguments suggest that a base reality exists beyond the confines of our virtual universe. This base reality is the foundation around which our virtual universe is constructed and is necessary for the simulation to exist. Additionally, theoretical frameworks like quantum physics imply that our universe is governed by fundamental principles that may originate from a foundational reality outside of our virtual world. These arguments offer intriguing insights into the nature of our reality and the possibility of worlds beyond our simulated universe, despite the absence of direct proof of a fundamental reality. Our search for the true essence of reality remains an ongoing study as we endeavor to uncover its mysteries. Number 2. Countless parallel universes. The concept of parallel universes, also known as the multiverse, has intrigued both philosophers and physicists by offering a glimpse into an infinitely imaginative existence. Despite being theoretical, various physics theories lend theoretical support to the idea of an infinite number of parallel universes. One such hypothesis is based on wave function collapse and quantum mechanics.
I've said it before and I'll say it again. Quantum mechanics is weird. It's also hard to make videos about, but we're doing it. It is the physics of the super tiny, and it's built around the idea that energy isn't a smooth spectrum. It can only come in set amounts. And as weird as the implications of that are, it's stood up to every experimental test we've thrown at it, and as we've learned more about it, we've gotten better at using it to solve problems.
Here, the rules of quantum mechanics. Your time starts now.
Well, the most basic version I know of is Feynman's version, which essentially says particles are particles and they hop from place to place with a particular probability. And the probability that a particle that's at some place will be at some different place. It uses a quantity called the action, which is to do with the mass of the particle and the time and the distance. So you basically calculate these little quantities, which are to do with something called the action, and you add them up. So if I start with an electron in one corner of the room, and I say, what's the probability at some time later it'll be somewhere else? Then at every point in the room, you can assign a probability that it will be there at a later point with one simple rule, and that's it.
The many worlds interpretation suggests that each quantum event causes several universes to branch out, each representing a different outcome. According to this view, every possible combination of quantum events takes place in a different parallel universe, creating an endless number of parallel realities. String theory, a framework that aims to unify fundamental forces in physics, suggests the presence of dimensions other than the well-known 3 spatial and 1 temporal dimension. Parallel universes with distinct physical constants and laws may arise from these additional dimensions. Although direct observation of conclusive evidence of parallel worlds is still elusive, these theoretical frameworks present exciting opportunities to understand the nature of reality beyond our own. The quest for evidence of parallel universes, which continues as we push the limits of physics, is a tribute to the endless curiosity and imagination of humanity. Number 1. Countless multiverses. The concept of a multiverse, which proposes the existence of an infinite number of worlds alongside our own, is a complex idea that continues to challenge theoretical physics and our understanding of reality. There are several theories that provide convincing support for the existence of a vast multiverse, but direct evidence is still lacking. One such theory is the concept of actual inflation, which suggests that the universe goes through multiple cycles of inflation, resulting in the creation of numerous pocket universes within a larger cosmic landscape. The diversity of the multiverse can be explained by the unique qualities and laws of physics that govern each pocket universe. Additionally, a framework for unifying fundamental forces called string theory also proposes the possibility of multiple worlds. According to the equations of string theory, there could be spatial dimensions beyond the well-known 3, leading to the existence of a wide range of distinct vacuum states, each representing a different world.
How much do we still does not know about the universe?
Yeah, so you might have heard of dark matter and dark energy. Dark matter, we can measure it. It's 85% of the gravity of the universe, and we don't know what's causing it. It's not black holes or dark stars. We don't know. It is not any of what is familiar to us. It's a mystery. Dark energy, this mysterious pressure in the vacuum of space, forcing the universe to accelerate in its expansion. We don't know what's causing that either. If you add those up, it's 96% of what is driving the universe. So we know enough about the universe to quantify our ignorance. And everything you know and love, the laws of physics, chemistry, biology, are in 4% of what is driving the cosmos.
That is incredible.
That's it for today's video. Thanks for watching. For more videos like this one, be sure to subscribe and hit the like button. We'd also love to know your thoughts in the comments below. We'll see you in the next video.